Alright, today we are going to graph this equation here, or this function, on a coordinate plane. Here's our coordinate plane. We're going to use GeoGebra to do that. And so since we're going to graph that function, the first thing we need to do when graphing a quadratic function is identify a, b, and c. And so since we're looking at this in standard form, a is the coefficient to our variable squared, and therefore our coefficient to our variable squared is 1. B is the coefficient to our variable, and so this coefficient is -6. I'm going to put that in there. And then we have the constant, which is 3. C is our constant, and so 3 will be our constant. Now that we've identified A, B, and C, we can start finding the vertex. Remember, we have to do three things. We have to find the vertex, we have to graph it, and we have to determine whether or not it is a minimum or a maximum. And so when I'm finding out what the vertex is, I'm going to plug in B and A into this equation to find the x value of the vertex. And I've placed my vertex in the middle of my chart. That way I know exactly where it is, and this is where the x value goes. And so once I start putting the information in, when I put in this -6, this is the opposite of B, and so the opposite of -6 would be a +6. Divided by 2 times A, or 2 times 1. And so that's essentially 6 divided by 2, which would give me 3. So the x value of my vertex is 3. So I'm going to put that in. Now what I'm going to do is I'm going to take this 3 here, and I'm going to put it in. I'm going to take this 3 and I'm going to put it into the equation for x. Everywhere I see x, I'm going to put it into that equation. Once I do that, what I'm going to get out of it, what I'm going to get from my y value, is a -6. Now here comes the tricky part when dealing with quadratics. Everybody asks, well, how do I find the rest of the x's? What do I use for my x values to solve for y? And that's an age-old question. Students ask that all the time. My answer is, when you are graphing a quadratic, you have to realize that they're symmetrical. Parabolas. That is the graph of a quadratic. They're always symmetrical. And so since they're symmetrical, let's think of a butterfly's wings. They're the same on each side. They're just reflections of each other. And so it's the same with the parabola. And so since they're reflections of each other, what I'm going to do is select x values that are of equal distance away from this x value in the middle. For example, if this is a 3 in the middle, I'm going to select a 4 right here for my next x value, but to keep it symmetrical, I'm going to select a 2 right here because it's the same distance from 3 that 4 is. Then I'm going to select a 5 here and a 1 here. Why? Because the 1 is the same distance away from 3 as the 5 is. 3 minus 1 is 2. 5 minus 3 is 2. They're the same distance away. And so just like a butterfly's wings, I want to keep it symmetrical. And this is why I want to keep it symmetrical. It's so easy when you think of it like this. I'm going to plug this 1 in to every x just like I did with the 3 earlier. Once I plug the 1 in for every x, then I know for the y value I'd get back a -2. Here's the trick. I can also say that 5 will have a y value of a -2. Why? Because they are symmetrical. And I'll show you this in the graph in just a minute. I can plug in the 2 in for my x values. I would get back a -5. That means your 4, because it's the same distance away from the original 3, would give you a -5 value for y as well. Why? Because it's symmetrical. Right? So what we're going to do now is take the information from our XY table. First, the first thing we need to do is determine whether our vertex is a minimum or a maximum. There are a couple ways to do that. You can look at the graph or you can look at the equation. If I'm looking at the equation, I'm looking for the A value. If your A value is positive, you have a minimum. If your A value is negative, you have a maximum. You can also look at the graph, and I'll show you how to do that in just a minute. Let's plot some of these points. So let's plot 3, -6 first. Here's 3. Here's -6. Plot. Let's go ahead and plot 2, -5. 2, -5. 4, -5. Now, are you seeing how they're symmetrical? Let's take a look at it again. We said 2, -5 and 4, -5 would be symmetrical, just like butterfly's wings. Well, let's look at that. If point A right here, or that's our vertex, is in the middle, then B and C are then symmetrical in terms of that vertex, just like a butterfly's wings. Let's look at the next one. 1, -2 here, and 5, -2 here. Okay, all our points are plotted. The next step is then to connect your points with a smooth curve. And keep in mind that this curve needs to be smooth because this is a quadratic. It's raised to the second power. That means it has some exponential things going on in there. So your curve is going to be smooth. And so I'm going to go ahead and graph that. And you see how the graph goes along every point here that we plotted. So our math was correct. The software proves that our math was correct here. And so let's see how to determine whether or not it's a maximum or a minimum. A minimum means that you can see the lowest point in the graph. Well, I'm looking at this graph, and I'm going to move around. I'm looking at this graph, and I don't see any point lower than A. Therefore, this graph has a minimum. If I try to find its maximum point, I can't, because this parabola will go into positive infinity on the y-axis. It does not have a maximum because it will go on forever. And as you can see, I'm still going. I'm at a y value of 57 right now, and I'm still going. It's going to keep going because it'll go into infinity. However, it does have a minimum because I can determine its smallest point on the y-axis, and we'll get back to that in just a minute. I was making a point that it goes into infinity, and so now I have to go all the way back down to get to the minimum point, which is a -6. So the lowest it'll go is -6, the highest it'll go is to infinity. So this graph does in fact have a minimum. I need you to complete all 6 problems on that page. Have a great day.